Hello everyone, this is Raihanuddin and I am a Marie Curie doctoral researcher pursuing my PhD at the University of Cagliari, Italy. So this is my pleasure to introduce Professor Emilio Gianni from University of Cagliari, Italy. So Professor Gianni is an associate professor in the electrical energy systems group at the University of Cagliari, where he has been serving since January 2020. He graduated with full marks in electrical engineering from the University of Cagliari in 1999 and obtained his PhD in electronic and computer engineering in 2005. He is also qualified as a professional engineer and holds the National Scientific Qualification as a full professor in electrical engineering. Professor Gianni is a senior member of IEEE and member of Italian Electrotechnical and Electronics Association. Professor Gianni has authored more than 120 scientific papers and several book chapters, mainly in the fields of smart grids, renewable energy integration, distributed energy resources, and energy system planning. His current research focuses on high, medium, and low voltage power grid planning, especially with the integration of renewable energy sources, distributed generation, smart grids, energy storage systems, renewable energy communities, electric vehicles, and energy efficiency in buildings. So let's welcome Professor Gianni to talk on his presentation on renewable energy communities, EU regulatory framework, and Italian case studies. Hello, Professor. Professor, we can't hear you.
Yes. Okay, perfect.
Yeah.
Thank you, Ryan, and thank you for all the people that are here today. And I hope you can stay awake for all the presentation. The topic of this presentation is about renewable energy communities. I can share the presentation. It's important to say you before starting this presentation that this was a topic that I started working 4 years ago when there was the first drafts of the regulation of European Community. And the first of all my boss doesn't believe so much on this research topic. So also you, if your boss doesn't believe in you, you go ahead the same. Because I'm working for 4 years on this topic. So this is my presentation, and the outline of the presentation is related to the European regulation, first of all, and we will see the two different of energy communities, renewable energy communities or citizen energy communities, and also a specific framework that is related to the collective self-consumption.
Emilio, sorry.
Yeah.
Could you share the presentation?
Oh, sorry.
Yeah, Professor, actually, our presentation is not visible in our side. Yeah,
No,
now it's okay.
No, now it's okay.
Perfect. You can start again. Okay, let me see.
Yes, Professor, now it's visible perfectly.
Yes,
so
yes, but I'm trying to share. Okay, now it could be okay.
Yeah, now it's okay.
Are you saying everything? Perfect. Okay,
Yeah,
this is the outline of the presentation. We will see, first of all, the regulation, the European regulation about renewable energy and renewable energy communities. And in particular, we see the renewable energy communities or citizen energy communities that are two frameworks of the same kind of sharing of electricity produced by renewable or non-renewable electricity, and a particular case is given by the collective self-consumption groups. We will see what we mean with this term, and we will see the possible configuration of this kind of renewable energy communities according to the Italian regulation and the incentive schemes, and also the last part will be about the DSO perspective about this kind of new frameworks that are being developed in the distribution networks. In general, if we start about the principle, why the EU care about the renewable energy, there are several reasons about this. The first of all maybe is the reason that we need a more environmentally sustainable energy system, and we need to reduce the CO2 emissions, in particular from coal, thermoelectric power plants, and also in order to obtain this is necessary to increase the penetration of renewable energy sources in the energy mix. Another reason, because there is a lot of interest on renewable energy, is related to the use of these new employments, new jobs that can be created with renewable energy. In general, the regulation, the European regulation related to renewable energy started in 2001, and there are several directives. The most important for renewable energy communities started in 2018, and is this one, Renewable Energy Directive, RED II, that defined and revised the renewable energy targets for 2013. And currently we are in this period of regulation, more 2019 and more, and is related to the Green Deal, that is related to all the development of renewable energy in all Europe. In particular, one of the policies, the main policies that was developed by the European Commission, was this package. This package is called Clean Energy for All Europeans, and in particular, this package has several field of actions. In particular, there is the energy performance in building, the development of renewable energy, and the energy efficiency in general. And in particular, there are the need of all the countries to have a PNIEC, that means a plan for the development of renewable energy in each member of the European community. And also there are some aspects related to the new market designs for electricity, in particular local market designs that include also the small customers that are connected to grid. Here there are also the several steps, the different directives that we had in Europe. I was saying before, the RED II directive was the most important for the development of energy communities. Also the EEM directive was very important because it was related to the rules of the electricity market. And after those two directives, in Italy there was later the PNIEC, the National Plan for Energy and Climate, and later again in 2020 and June 2021 there was the national transposition of the European directives, and but only 3 years later, in January 2024, the possibility of implementation of renewable energy community was reached. And now we are in Italy creating this kind of energy communities and that are going to be in place. In general, energy communities are considered to be important because they involve a lot of citizens, they involve their participation, in the management of the system, in terms that also the group of citizens can be aggregated together. They can build new photovoltaic plants or other renewable generation plants, and they can share the electricity together. In particular, this is not a simple action, no, but it's necessary to do some several steps in order to create the energy community, because first of all, the energy community is not only a simple group of citizens, but it's necessary also to define a legal entity. And this legal entity is based on open and voluntary participation, and has to be controlled by the members or shareholders in case all these members are located very close to the production plants. In general, which are the members or shareholders of this kind of energy communities? In general, could be the natural persons, local authorities, also small or medium-sized enterprises. And the objective of the energy community in general, the renewable energy community, is to provide environmental, economic, and social community benefits rather than financial profits. Even though there is an economic incentive that is focused about the development of these energy communities. So in general, the renewable energy communities are entitled to produce, consume, store, and sell renewable energy in a very small geographical area. And this renewable energy can be shared about within the area, considering all the members of the renewable energy community. And in particular, through this aggregation, is possible to have the benefits I mentioned before for all the people of the members that are included within the renewable energy community. There are the main directives are the first, the renewable energy directive, that was focused on the increasing of the number of the quantity of renewable energy installed in the networks. The second directive that is very important is this one related to the electricity market in particular. This directive was designed to empower customers to become active market participants. So it's very important for this directive that the people is more aware about the value of electricity, is more aware that they can produce energy, they can obtain this energy with lower prices, and so on. This means the active involvement of customers. In general, there are two names that are used for the directive. Renewable, the RED II directive speaks about renewable energy communities, and the EM directive speaks about CSC, Citizens Energy Communities framework. What is different among renewable or CNC energy communities? The main difference is that in the community energy, citizen energy community, the production of electricity cannot be only renewable, but could be also other kind of electricity, also traditional electricity obtained with the fuel, with fossil fuel. So this is the main deep difference. In general, also the citizen energy communities are regulated in a similar way to renewable energy communities. For citizen energy communities, in general, there are no incentives, in Italy at least, and these incentives are all only related to the renewable energy communities. So this is a comparison among the renewable energy communities and citizen energy communities. First of all, not different of the legal basis from EU, Renewable Energy Directive or Internal Electricity Market Directive. In some cases, there is the possibility of share the electricity produced locally, and only in the first case, this electricity can be produced by renewable energy. In general, no, the primary purpose, as I was said before, in the first case is to obtain environmental, economic, and social community benefits. In the other case, the most important thing, the consumer empowerment and market participation. Another point is related to the local proximity-based, the geographical constraint. With citizen energy communities, there are no specific geographical limitation. In general, as you can see here, it's possible to generate, consume, storage, sale, and share electricity energy in the two cases, and the energy sharing has to be explicitly allowed among members. But in the case of citizen energy community, there is no specific focus on energy sharing. In general, the two possibilities are considered or can be developed in future models of energy sharing or energy participation or involvement of citizens in the electricity markets. Coming back to the scheme of renewable energy communities, in this slide there is an example of what we mean with the renewable energy community. And as you can see here, there are two aggregates of several customers and other places, other buildings where there is maybe the production of renewable energy, electricity obtained with the photovoltaics in this case. And there is also other customers that can be equipped with photovoltaics or electric vehicles and so on. All the groups of members in this case are connected to the same network, or they are very close. In this case, maybe there are two feeders that the two feeders are connected to the same medium voltage, low voltage substation. In this case, also is necessary to create a legal entity among of the groups that participate to the renewable energy communities. This is another scheme that represents the renewable energy community, and an important aspect is to consider that in the electricity energy community, renewable energy community, is very important the equipment necessary to control, to share the information about the users of the energy community. And so we need not only the power network, but we need also the ICT network. This is the things that also we are studying in the fitness project, because many of these ways of communicate or control the loads or the generation are one of the objectives of fitness project. And many of you are working or will work on these topics. So this is very important for this project. The community manager, as depicted in this slide, is have to control in general to measure, to monitor the consumptions of the members of the energy communities. But in the future, the same community manager can manage the electricity that is consumed or produced, also to offer services to the DSO. And this is also another point, and very important point for fitness projects. Here there is another scheme that shows the network of the past, in the future. Now, in the past, the user load also for small citizens, for residential users. In general, they consume from electricity from the grid, but they are not able to control their load. And when they need the electricity, they buy the electricity from the grid. But in the future, the things will change, and it will be possible to control the time of consumption of electricity by means of energy management units, and in particular will be possible, for instance, to buy the electricity when it costs less, or to acquire the electricity, to provide electricity from the grid in a renewable energy context, no? Renewable energy community context. So that means I consume electricity only when there is electricity produced by renewable generation. This is, for example, another option that can be have in Italy, and this is related to the collective self-consumption groups. The collective self-consumption groups is a specific renewable energy community in which all the people, all the users of the renewable energy community are located in the same building. This is a typical situation that we can have in our cities, and as you can see here, in this case, we have a PV power plant that is built by all the condominium. The electricity that is produced by this photovoltaic plant can be shared and can be sent to the grid, and also and can be shared with the electricity grid, and later can be again withdrawn by the customers of the collective self-consumption groups. In general, the development of renewable energy communities is very important, as I said before, for the project, because there are several topics that are related to the development of renewable energy communities, like for instance, the smart building automation, the management of smart distribution networks, smart grid, the problems of renewable energy integration and emission reduction, and so on. Another part is related to the peer-to-peer energy trading, and in this case also in University of Cagliari we are studying several options in order to realize this peer-to-peer energy trading, like the use of blockchain or similar things. This is another scheme that can be adopted with the renewable energy communities. This is the scheme in general of the virtual power plant, in which by means of the renewable energy community aggregator is possible to control a lot of distributed resources, and the distributed resources are the same that are within the renewable energy community. Coming back to the situation in Italy, I said before that in the energy community it is necessary to define the geographical space where the members are located. In the past, in the first draft of the regulation, it was possible to consider only the users that are located near the secondary substations. That means that the distance from the substation is about 1 kilometer, and the users are about 200-300. But with the actual regulation, the limit is considered related to the high voltage, mid voltage substation, and in this case we can have also more than 20,000 users, and the extension of the geographical area is about in a radius of 20 kilometers power line extension. That means that with the new regulation, we can have also several municipalities within the same area. For instance, in some municipalities, there can be users that are only passive or mixed user, passive and active, or only active, and so on. So all the combinations can be used for creating renewable energy communities. Here also there is another scheme of the possible usage of renewable energy communities, like virtual power plant. And in that case, now, as you know, maybe virtual power plant enables the concept of Internet of Energy, so you can manage the energy production and consumption in a very large area. In Italy, there was a large development of this regulation and large adoption of the development of energy communities. And in general, in order to improve the creation of these renewable energy communities, also several maps have been created by GSC. GSC is the entity that is devoted to incentivation of renewable energy electricity in Italy. And for each place, for each region of Sardinia, is possible to find the area, the related area to the primary substation, and is it possible to define the area where the people can be aggregated to create new renewable energy communities. As an important point is related to the incentivization of the renewable energy communities. In particular, the incentives are related only to the self-consumption, the self-consumed electricity. So if the group of people, or for PMI, or public bodies that are included within the renewable electricity configuration, they can be incentivized only for the electricity that is produced and consumed in the same time. This is an important point, and this for this electricity, an incentive of about 110 euros per megawatt hour is provided to the renewable energy community. In general, the renewable energy in the renewable energy community, there is the need for, in order to be created, to realize new electricity renewable generation plants. These plants, in general, inject the excess of electricity in the grid, and this excess of electricity of the grid is paid with the value that is that we have in the market. In general, this value is variable. It could be 50 euros per megawatt hour, but it could be also 200 euros per megawatt hour. And this is the first part of the money that can be obtained by new renewable electricity production. But if this plant is dedicated in particular to a renewable energy community, there is also the options, the new advantages, economic advantages that are related to the shared electricity. In this case, the value is about 110 euros per megawatt hour, depending on the size of the plant and the cost, the value of the electricity in the market. And also there is another return for lower system costs for self-consumption that is about 9 euros per megawatt hour. So in general, as we see later, is it possible also to evaluate, to make some assumptions, to do some techno-economic evaluations about the advantages or not, and the right sizing of renewable energy communities generation plants. This is another information about the price and the advantages that we can have with the shared electricity. And in particular, there are also different correction factors, and there are the variability of incentives depending on the price of the electricity in the market. This is the first electricity renewable energy community that was created in Italy. I participate to this renewable energy community creation, and this is the energy community of Magliano Alpi. Magliano Alpi is a very small village that is located north of Italy, and this is the paper that was related to this first development of renewable energy community. And this is a very interesting example because you can see that it contains all the specifications and all the characteristics of the renewable energy community as requested by the regulation. In particular, in this case, there are very low number of participants, very simple energy community. There are public participants and private participants. In particular, there is a PV system that was installed in the roof of the municipality, and there is a school. The ownership is of the school is always the municipality, and there is also the gym, also owned by the municipality. Within the renewable energy community, there are 3 families and also a small business. This is the first energy community that was created in Italy. Sorry, but in some cases the PowerPoint doesn't go ahead. Okay. This is the some specification about the electricity, the renewable energy community, and as you can see here, there is the PV plant. The PV plant is about 20 kVp. And is located in the municipality, and there are also the other users that are public buildings or residential with the traditional capacity used in Italy for small customers, about 3 kilowatts or 4.5 kilowatts per each user. What we did with this energy community, we installed also smart meters in each premises of the users, and with this smart metering was possible also to evaluate in real time the production and consumption of electricity, and to do also the statistics and to evaluate the value of the advantages or the incentives for the renewable energy communities. We did different studies on these small renewable energy communities. This is a paper that we publish after 3 years operation of the renewable energy community, and was possible in this case to evaluate also the economic metrics related to the energy communities. No, because the coincidence of the consumption or the production changes, or if you are in the fall, in winter, summer, or in spring, and it's important to evaluate for each season, for each day, which will be the advantage, the economic advantage for the participation in the energy community. This is, for instance, this histogram. There are the information about the electricity that is withdrawn from the grid, injected to the grid, and shared. In particular, is possible to see here that the electricity withdrawn from the grid increased in 2022 because they changed all the air conditioning system, and they go through a heat pump that was electrified instead of using other kind of air conditioning systems. Because was electrified. Why was electrified? Because they installed the photovoltaic plant, and they want to use the photovoltaic plant to feed the air conditioning system. And in particular, in this case, this slide, you can see in particular one parameter that we defined how is defined this parameter? We call this parameter renewable energy community economic efficiency, and is given by the ratio among sold electricity and the injected electricity. So the objective is to share all the injected electricity that is injected to the network. But as you can see in this representation, this picture, in 2021, the first quartile, the second quartile, and so on, in general, the shared electricity was about the 60% of or less than the 60% of the electricity that was injected. Only after the 2021 and 2022, the value of the electricity, in particular in 2022 or 23, as you can see here, the injected electricity was increased the shared electricity compared with injected electricity, because for the same reason I was saying before, because they increased the electricity consumption with the air conditioning system. And we did also some evaluations about the economic benefits of the electricity, and this is the data for 1 year. They shared about 32,000 kilowatt hours. They injected the electricity about 41,000 kilowatt hours, but the demand was more. Here they are the values of the incentive revenues, that about 3,060 euros, 3,036 euros, and there was the rebate for network charge, about also 300 euros, and the fed-in revenues. Considering all the whole income of the incentive and the fed-in revenues, it was possible to share to the 6 customers of the renewable energy communities about 200 euros per year for each customer. This is another scheme for the renewable energy community, and in particular, in this case, we have the techno-economic analysis of port renewable energy communities. In this case, the loads are in this case the port, the industrial port, and there was a possibility also to feed the buildings related to the services of the port, not only the loads that are represented in this case, the consumption of the boats for the services when they are in the port. And in particular, this is another example that we developed, also is related to the coordinated battery storage management in residential renewable communities. In this case, we did different comparisons. In particular, the comparison was done related to the use of distributed battery energy storage system. Like in this case, the battery is located in the premises of the users, so inside the apartments, or in the second case, a concentrated battery energy system is located not in the apartments, but connected directly to the PV system that's installed in the apartment. And in this case, we have clearly the comparison. We have to do the comparison about the load of all the apartments that we can have in all the building, and in the black one, the black line here shows the quantity of electricity that can be shared in this context. This situation is the situation without BESS, but in our study we tried to add the BESS, and the BESS was tried to be added distributed or concentrated. And this is the situation that we obtain in case we have a 24 kilowatt-hour distribution BESS or 40 kilowatt-hour distributed BESS compared with the two cases, no, with the concentrated BESS or distributed BESS. And we did also in this case all the evaluations of the electricity shared or the electricity that is injected to the grid, like in this case, no, comparing the value, considering the time of injection or consumption of electricity and so on, and compare the two cases. As you can see here, the best situation for these apartments is the one with the 40 kilowatt-hour distributed BESS or centralized BESS. There are not so much difference among the two situations, but maybe the main difference is related to the losses of the electricity that we have during charging and discharging of the batteries. Also, there are the numbers here of the advantages, the value of the electricity share and the energy that is the overall economic benefit in all these cases. This is the case that I mentioned before about the use of renewable energy community in a case study where there is a renewable energy community with the port, and in this case was necessary also to define the best sites of the photovoltaics and storage system for this kind of renewable energy community. We did different simulations in this case. That the objective again was to optimize the size of photovoltaics and storage that can be used for the renewable energy community in a port. And the case were three cases: only PV, or PV and energy storage system, or PV and energy system and electricity management system. We did different simulations considering different price of electricity, both from the grid, and we did also all the case studies and the combinations. In particular, we consider these two business as usual case with a PV plant of 150 kVp and an electricity storage of 300 kilowatt hours, or a PV plant of 2050 kVp and electricity storage system of 40-50 kilowatt hours. And we did a lot of studies here about considering different prices of the equipment, the cost of PV, for instance here 800 euro per kVp, and electricity storage system unitary cost of 600 euros per kVp, and so on. We did all the different simulations considering 20 years horizon of period of optimization, and obtained also the net present value of each combination. I'm going too long with the presentation, so I will skip quickly this part. I will go to the final part of the presentation related to the DSO perspective. So up to now we talk about the development of renewable energy communities in the networks, and maybe there will be also some problems for the DSO, because the DSO is seeing a lot of renewable electricity that is going to be connected to the electricity networks. And what is the problem of this renewable generation in distribution networks? Maybe the first problem is related to the bidirectional flows, because in general the distribution system were conceived to only to be operated like passive networks, when the load, the final customer only consume electricity. Now the things are changing, and this caused a lot of voltage rise problems, and this voltage rise usually also, at least in Italy, cause the disconnection of the PV plants. In order to control better the system, it's necessary to have real-time monitoring systems of all this production and also of the load, and also it's necessary to take actions about the control of the load and the customers. This is another important point, in particular for one of our PhDs that we will work on the fitness project. Know that the topic is the decentralized control of the resources of the users and the production in the network. Another important point is the necessity of flexibility resources. What are flexible resources? Flexible resources are resources that can be used in case of excessive generation, over generation, or in general if there is not enough generation, and they can be used to solve local congestions in networks and so on. We are going to have also new markets for flexibility, new markets from that can be realized considering the interactions among TSOs and DSOs, and also this kind of new approaches, new kind of management of the distribution networks can be very useful for us, because we need to define new models, new optimization tools, new control and management tools for networks and the resources, the electricity resources, the energy resources that are installed in the networks. Anyway, there is also an impact on the network planning and the investments, because if the increasing of penetration of the renewable generation can require the reinforcements of networks, can require the use of the more use of battery energy storage systems and so on. All this network planning and investment can be done in an optimal way, and this is also another important topic of our research. Finally, here there are the main publications that I wrote in the last years. We started to publish papers on renewable energy communities in 2021, and the last paper was published in March 2026. This is my last paper that I published recently. All this paper can be accessed by all of you, so you can also investigate more about this topic to study the things we did in our university. Maybe this was the last slide, and I'm open to the questions if there are questions from the floor.
Thank you, Professor, for your valuable presentation on renewable energy communities. So, guys, now, if you have any question, please ask to the professor. I think professor will give you the answer shortly.
Yeah, you can write also the question if you like.
Yeah.
Anyway, the presentation will be shared about all of you. Also, you are free also to write emails if you like. There is my email on the first page of the presentation. emilio.giani@unica.it. Okay, I don't know if there are no questions. Maybe I was too fast or not, or was too difficult, the things I was saying. Anyway, I will wait.
Professor, actually, we
Yeah.
have a on question Sharma Alia just asked a question like, are there any peer-to-peer sharing energy communities in Italy?
I'm sorry, because there was a question about the peer-to-peer sharing.
Yeah.
Yeah, currently there are no regulation about this kind of market for energy local markets, no? Because there are there is no still the regulation available. But in the future, we can have also this kind of markets. Currently, we do only simulations, making some hypotheses about this kind of local markets, but they are not in place.
Okay, I think Alia, you got your answer. Thank you for your question, and also thank you for your answer, Professor. So I think there are a few guys who are just asking the question here.
Hi, can you hear me?
Yeah.
Yes, Maria, we can hear you.
Sorry, I'm Elia. I asked the question about peer-to-peer sharing. So I'm from Aalto University, and my research is towards energy communities. And I was studying about this peer-to-peer scenarios, and I found few pilot projects that are currently operating in Switzerland and in Australia. In India also there is one pilot project, but in European Union I wasn't able to find any. So I thought it was better to ask you about it, but your answer clarified my questions. So I just want to ask, what are the regulatory exemptions that are required for this P2P sharing in European Unions? Are there any possibility in future, or there won't be any P2P sharing here?
I'm sorry, because I don't understand very well the question, because you mean that in European there are no examples of energy communities?
There may be, but I can't find it. I have found it in Switzerland, and there are few pilot cases in India, in Australia, but I can't find any in European Union. Maybe there are,
No.
but I can't find.
I think it's the contrary. I think it's the contrary, because we have a lot of examples. No, also if you look to my papers, you can find a lot of examples of electricity communities in all Europe. An important point is that the model that we have in Italy is not equal to the model that is in Switzerland and so on.
Yes,
So
yes,
each of the states are different models of renewable energy communities, because the concept of renewable energy communities is a general concept defined by the European Commission, but each state define with its regulation how is the combination, how is the framework for the local renewable energy communities. But if you look, there are a lot of examples also in Europe, more than outside of Europe.
Yes, there are many examples of energy communities, but I was asking about some that include P2P sharing. That was my question.
Sorry, because I cannot hear very well. You can repeat the question if the question there is still the question.
I was asking about, are there any currently existing P2P energy sharing communities in Europe?
But I'm not able to catch the question. I'm sorry.
Oh, Professor, I think she's asking that is there any existing peer-to-peer sharing
In
energy
Europe,
communities?
you are saying in
Yeah, in
Europe if
Europe.
there are other kind of peer-to-peer. I'm not sure of that. I'm not sure of that. If there are maybe some, there are different markets, but peer-to-peer among customers, I think it is not still possible in Europe. There are no similar markets. There is a possibility for the markets for flexibility. So the DSO acquires the services and the customers can exchange their services with the TSO, but not among customers, like peer-to-peer market.
Okay. Thank you. I got my answer.
Welcome, welcome.
Professor, I have one question. This is Sai Krishna from Imperial College. So my question is, in future, we'll be saving more of energy communities, but do you see that, I mean, what are the minimum requirements for some part of the network to be converted to an energy community? Is it, do they require to have sufficient generation or sufficient storage, or what are the general constraints to be considered for converting one part of the network to energy community?
Yeah, in order to realize the energy community, maybe you are right if I understand very well, it's necessary to build new generation plants, and also the storage will be very important, no? Because I don't know if all the countries we adopt the same regulation of Italy. It's necessary to produce electricity and consume in the same time. So if you're not able to produce electricity and consume the electricity, you need the storage, storage for do the time shifting of the electricity, and improve the self-consumption rates within the electricity, within the energy community.
Okay, thank you.
Welcome. Anyway,
Yes,
if you have some questions more, maybe you can send to my email the question. I will be happy to answer to you.
Okay, guys. So actually,